worry. Next up is Anders from Halon. I just want to add that if you are a speaker and you know that you're up next, please go like 10 minutes before it's your turn. Go get a mic. All right?
Is it possible to also get the presentation on the screen here? Oh, there it is. Thank you so much. All right. Thank you. Thank you for having me here. It's been quite a while since I was at the Netnod Meeting, but it's great to see a lot of familiar and friendly faces. Many of you I know since when I was living in Stockholm when I did my master's thesis at TL2 back in 2010. Had the pleasure to have Ellen as my boss. And I'm here today to talk about email encryption. I'm the co-founder of a company called Halon, which develops email infrastructure software for large service providers. I'm also a co-chair of the Data and Identity Protection Committee of an organization called MOG. MOG is an international organization which brings together large mailbox providers and other messaging providers and large senders to get them to collaborate to make communication better and safer for users. And this particular committee was created as a response to the disclosures made by Snowden when it became public that there was a lot of surveillance going on for email. I've been working with email since 2006, and I really like email. I mean, it's an old protocol. Some people probably wondering, like, isn't it about to die pretty soon? Maybe, but as it stands today, I don't really think we have a good alternative to replace email, because we don't have that many vendor-agnostic addressing schemes. We have post addresses, we have phone numbers, email addresses, but I'm not aware of that many other globally addressable vendor-agnostic addressing schemes. And I think that overall, email is a nice open protocol that aligns well with the principal design of the open internet that I really like. It certainly has its flaws, but I think for now we better work together to improve email until we have a replacement. Today I will be talking specifically about transport encryption. It's not the same thing as end-to-end. End-to-end encryption is also nice, but it comes with its particular challenges for anti-abuse and stuff like that. And I think transport encryption should be like the first thing we get right. And transport encryption is what happens between email servers. So if you email me from your company address, you might be on Microsoft 365. Transport encryption is what happens when Microsoft 365 makes the connection to the Halon email server, as opposed to the client-server connection between your devices. And this is all based on TLS. TLS is the de facto transport encryption protocol that we've had for a very, very long time, and what makes a lot of things on the internet work. Like, how would you do online banking or, all these other things we do, e-commerce, if we didn't have proper transport and encryption? And you might then ask, like, what's the problem here? Why am I standing here talking to you about this? Because we've had star TLS for a long time for email. And the thing is, email is an old protocol, which we have been improving iteratively. And the two questions were like, how do we enforce encryption and how do we authenticate it? How do we know that we're talking to the right party? Because if TLS is not enforced, we're subject to downgrade attacks. Like, one server talks to another server, but someone sits in the middle and just, messes with the connection so that it downgrades to plain text. And if we don't have a way to authenticate, we can have a man in the middle. And that's the problem that we've had for a very long time with the email protocol. So this is a way to illustrate the problem. Like, we've had a proper TLS when your client devices, like your phone, your laptops, authenticate with your email server. That's not a problem. The problem is server to server. When Microsoft speaks to Gmail, or when your company server speaks to another company server, that has not been properly secured for a very, very long time. And this is what made a lot of the pervasive monitoring possible. And then another question is like, email is old. We've been trying to secure things for a long time. Like, why has this not been solved a long time ago? And I think it is because it's not a straightforward problem to solve. And when you have a problem which is not straightforward to solve, then you will have a lot of opinions, a lot of perspective angles, and progress just happens to be very slow. Sometimes it might be for the better, but in this case, I think it was overdue, let's put it that way. And with other protocols, it's a lot easier. When you have client-to-server communication, like in the web browser, or when your Thunderbird email client authenticates with your email server, that's a lot simpler, because then you can enforce encryption by like choosing to use HTTPS or click some checkbox. But we can't really do that in server-to-server communication. And there are now two standards that are finally widely available and getting deployed as per the title of this presentation, Transport Encryption finally going mainstream. So we have these two protocols, DANE and MTA-STS. And these two protocols, they are very similar, and the solution is, I think, quite elegant. There's nothing on the receiving side that needs to happen in the actual software. All the intelligence is in the sending server, and the receiving domain. When you send an email, you have a recipient domain. Like if I send an email to Gmail, then gmail.com is the recipient domain. The recipient domain signals via DNS if TLS should be enforced, and if so, how to authenticate the certificate. And this is invisible to end users for good and bad. Good, because it makes it easy to roll out. Bad, because it's invisible. DANE was the first standard. It uses DNSSEC. DNSSEC does all the heavy lifting with DANE. MTA-STS, and I can't mention that MTA is the technical term for an email server that delivers email. It instead uses HTTPS and trust on first use. Why does MTA-STS exist when DANE was first? Well, some people do not use DNSSEC. Some countries don't have any meaningful DNSSEC deployment at all. In Sweden, we don't have this problem, but in other quite large countries like the US, they very much do. So we have those two competing standards. The DANE standard has been around for a long time, since 2014-ish, and we have support in all the major email software programs out there. If you were a pioneer, like back in if you were starting doing this back in 2017-ish, you might run into some problems, because back then people were still messing up DNSSEC a bit. But today, we have a large enough critical mass of operators using Dane. So if you would enable Dane in your email software today, when delivering email, you should not have a problem. You should just see an increase in security. So that's on the sending side. Like when you deliver email, you need to enable this Dane feature. On the receiving side, there is nothing you need to do in your software. You instead publish something in your DNS. And the nice thing about Dane is that if you have a lot of domain names pointing at the same place, which is the case for a lot of hosting providers, if you are hosting hundreds of thousands or millions of domain, all pointing at the same server, you only need to maintain Dane records for that server. So it's really quite convenient. And it looks like this. In this example, I took itf.org, a domain that you might be familiar with. And when delivering email, we do two things. We first look up which is the email server for this domain. That's the first thing here. itf.org happens to have their own email server, but if I was to email any one of you, chances are big that the MX would be something with outlook.com, because a lot of you uses Office 365, I think. The next thing we do is we look up a Dane record. It's called TLSA, which is basically to say that if I wanted to send an email to this server, which is port 25, give me. So this record answers two questions. Should I enforce an encryption? And if yes, what is the signature of the public key? And the nice thing about DNSSEC is that you can trust whatever we get back. So if the domain doesn't have DNSSEC, it has no Dane. If it is DNSSEC signed and we don't get a record, we know for sure that we're not going to enforce any encryption. And if we do get this record back, we know for sure that this is the key we're going to authenticate. So that's Dane, all pretty straightforward, and something that I encourage all of you to start using if you are an email administrator and is not already doing so. The number of Dane-enabled domain has been rising quite a bit, and if there is someone from one.com here, I can say big thank you, because you were responsible for the peak from 300,000 domains up to 1.6 million-ish. So that was a large number of domains that was enabled by one.com, starting to do DNS signing for all their domains, and also adding Dane records to their MXs. And you can see that the number of domains that support Dane is, by now, it's quite a bit. However, in terms of traffic volume, it's not as much as with MTA-STS, because this is what is used by Google and Microsoft. And you can imagine that something which Google and Microsoft does has quite a bit of volume. So it became an RFC in 2018. It was sort of born out of the committee in MOG that I'm part of. And the only reason it exists is because some regions have very low DNSSEC usage. So instead, it uses an HTTPS endpoint for each domain. That's one of the problems with MTA-STS. If you are a hosting provider with millions of domains, you would need millions of HTTPS endpoints. Obviously, they can be on the same server, vhost, stuff like that, but ultimately that's still what is required. And the protocol looks like this. We do a DNS lookup. That's the whole trust on first use thing. Like if there's a man-in-the-middle attack or anything during this initial DNS lookup, then we're screwed, right? But if we do get a DNS record here back on the MT-STS query, we will do an HTTPS query, which will tell us if we should enforce encryption, and if yes, what CN common names in the CA verified certificate that we should accept. So unlike Dane, which worked with a self-signed certificate, this requires a CA-signed certificate. Once we get this initial policy, the email software will continuously refresh it. So we will only be vulnerable for the first request. And email servers tend to be quite long running. So the security in reality is quite high here as well, because you have only this tiny opportunity of messing with it. All right, so if you're not doing Dane and MT-STS today, here are some sort of recommendations. First of all, if you're using Let's Encrypt, which is quite nice, definitely recommend using Let's Encrypt if you can. The recommendation is to use the option in Let's Encrypt to reuse the key. So rather than creating a new private key each time, enable the option to reuse the key, because in that way you don't need to update your DNS records every 90 days or whatever it is. Obviously, you can choose to rotate the keys every, as often as you think makes sense, but every 2-3 months is probably excessive. Secondly, when you do rotate your keys, automate the process and pre-publish the keys, because DNS has a TTL, and most importantly, you probably have 2 MXs. If you are polisen.se, you probably have MX1 and MX2 for your domain. Don't change both at the same time, because if you mess it up, well, you start having quite big deliver problems. There was a pretty big, important Swedish government institution which did this. They had 2 MXs, they had different certificates on them, and they replaced both at the same time and messed up both. And yeah, it took a while to realize what happened and for them to fix it. So do one at a time. With a few days in between. That's a quite good recommendation, I think. And should you still have a problem, it's nice to use something called TLS RPT, which will give you reports if there are TLS deliver problems to you. So it's a way for you to get insight into possible mistakes you have made with Dane or MT-STS. And also very important, as I've helped a lot of organizations roll out these types of encryption standards, we sometimes need to get in touch with organizations which have problems. And working who SOA and the postmaster addresses is very helpful, because sometimes it is really quite difficult to get in touch with people when things are not working. So that's super helpful. All right. So just some concluding thoughts. There's been a lot of talk like, how do we get DNSSEC adoption to, what do you say? How do we get higher adoption? DNSSEC adoption globally is not great. In certain regions, I think Denmark, Sweden, Netherlands, we have monetary incentives for the registrars, and to me it seems to work quite well. So I'm trying to advocate for these kind of incentives in other regions as well. There's a lot of people saying that we shouldn't, like, adoption of protocols should come by need and not by, you know, someone incentivizing. There's probably some truth to that, but I personally think that the incentive programs are really quite effective. Overall, in certain regions, there is quite a bit of hostility towards the DNSSEC. A very big European provider enabled DNSSEC a couple of years ago, messed it up, and everything went dark. Like, you know, they signed their own domains, and, you know, a lot of things are dependent on your domains. So a lot of things within that ISP broke, and their management basically said, we will never do DNSSEC, and they're still not doing DNSSEC. So there's that. US companies has been very slow, but I think that both Google and Microsoft are actually on the path to start doing DANE and DNSSEC. I never thought it would happen, but Google has now signed some of their MXs, and Microsoft, I think, from pressure from the European Union, DNSSEC is mandated for certain parts of the European Union. I think governmental institutions. So I think that has forced Microsoft to adapt here as well. And finally, like, should you do DANE or MTSTS? I would say for receiving, it's sufficient to do one. Like, if you're a Swedish organization, you are probably using DNSSEC, then I would recommend you do DANE. It's simple. But when it comes to sending, I don't see any options right now to enabling both DANE and MTSTS in your email software, because certain organizations are only doing MTSTS, others are only doing DANE. So if you enable both for your sending, you will get encryption to both. So I think that's where we are right now. And for the foreseeable future, we will have both standards. Always annoying with two competing standards, but it is what it is. All right, that was what I had to say. Do you have any questions or comments?
Hi. I mean, of course, transport encryption is nice to have and is long overdue, as you mentioned. But because they are both, prone to DNS hijacking, attacks, is there anything in the pipeline, as far as you know, for end-to-end encryption, like, for instance, like PGP encryption on the client, from end to end?
Yeah. I think one of the things holding it back is that email is an open protocol. Like anyone can send an email to anyone else. It's really quite fantastic, but there is a quite big abuse issue. The fact that it is open, it is free, or whatever you want to call it. Email has always had quite big abuse issues, and when you introduce end-to-end encryption, let's say that I have an endpoint where I publish my public key so that you can encrypt an email with my public key. Your provider, who will deliver the email, will not be able to do anti-abuse checking of it. And my provider, who want to protect itself from spam, also cannot do any checking. So I think that is that is the major reason why providers have been hampering the adoption of end-to-end encryption on email. Then there are also other challenges, you know, client software, how do we make it user-friendly enough, etc. But I work mainly with the service providers, and service providers, even today, they struggle quite a bit with the anti-abuse measures with email, and it would certainly be more difficult if they were not able to look at the content of the messages. All right, thank you.
Thank you very much, Anders.